Good day, everyone. One of the primary parts that we need to understand is how do we interact with virtual reality using gestures and interaction? How do we interact with the world to which we are transported to our senses? And how do we interact with virtual objects which we may or may not feel? It is always a challenge to decide on the type of gestures that we will need use while interacting with these virtual surroundings. Today's lecture aims at addressing these challenges and understanding the type of gesture that can be used in VR. Human computer interaction, as an important supporting technology of VR, provides a variety of interactive modes based on different functions and purposes, enabling people to obtain an immersive feeling in 3D virtual scenes. As an emerging technology, VR is a new interactive human computer interface. With the continuous development of interaction technology, VR has been widely used in many fields such as game, medical care, and education. In the future, interactions could be like the movie Player One, in that users could capture people's movements through wearable devices, become avatars, and interact with other people in the virtual world. As an increasing number of companies and scholars invest in the research of gesture interaction technology and related applications, gesture interactions have engaged a large proportion of the field of natural interaction. To simulate daily life operations in a virtual environment, it is necessary to track and recognize the hand movements to make the computer understand the true intention expressed by gestures and to perform related tasks. Gesture is a conscious or an unconscious movement of the hand, arm, or limb. Through gestures, people can express their interactions, intentions, and send out corresponding interactive information. Generally, gestures convey information or intention through physical movements of the face, limbs, or body. In VR environment, the posture or movement of the user's body is used as input, and the posture information of the user through the interaction device in the physical world is used as a system input. In the interaction process, users can not only generate gestures using hand, finger, and palm, but also generate gestures as an extension of the body through tools such as mouse, pen, and glove. Users can send simple commands to the system through gestures such as selecting, moving, and deleting, and can also express much more complex intents such as switching the current interactive scene, controlling the virtual objects, and performing virtual actions. In different situations, the same gestures may have different meanings due to the factors such as culture or geography. The understanding of gesture semantics is closely related to the cultural background, and the gestures can be classified and summarized according to the different situations. As stated earlier, gesture is a conscious or unconscious movement of the hand, arm, or limb. The gestures in the interaction process can be distinguished according to different spatiotemporal operation behaviors, different semantics, different interaction modes, and different interaction ranges. In the early interaction scenarios, the acquisition of gesture signals was mainly based on wearable sensor devices, such as data glove. With the deployment of mobile devices such as mobile phones and tablets, touch screens become popular. Consequently, the acquisition of gesture signals has developed into visual signal acquisition from computer cameras. In recent years, information acquisition based on high-tech equipment such as electromyographic signal acquisition has gradually become a research focus. Owing to the variability and complexity of the gesture, how to use the existing technology to process the input signal collected by the device, how to determine the spatial position and posture of the hand, and how to obtain an accurate recognition result have great impact on the effect of subsequent gesture interactions. Gesture recognition technology is mainly categorized into gesture recognition based on wearable sensor devices, gesture recognition based on touch devices, and gesture recognition based on computer vision. In the upcoming slides, we will be looking at the details of the gesture classification. According to the spatiotemporal operating state, gestures are generally classified into static gestures and dynamic gestures. A static gesture is a static spatial posture of a finger, palm, or arm at a certain moment. It usually only represents one interactive command and does not contain time series information. A dynamic gesture refers to the posture change in a finger, palm, or arm over a period of time. Accordingly, it also contains time information. The difference between the two is that the static gestures only include spatial gestures without causing changes in spatial position, whereas dynamic gestures are characterized by movements in spatial locations over time, such as waving gestures, which are typical dynamic gestures. Dynamic gestures also include conscious dynamic gestures and unconscious dynamic gestures, in which unconscious movements during physical activity are called unconscious dynamic gestures, and gestures for communication purposes are called conscious dynamic gestures. According to behavioral and cognitive technology, gestures are divided into manipulative gestures and communicative gestures according to whether they contain communication characters. Manipulative gestures is the action of controlling the state of the object through the hand arm movement, such as moving and rotating objects through the movement of the arm. The communicative gestures can be customized gestures with a specific information function. In a natural interaction situation, they are usually accompanied by verbal communication, mainly including symbolic gestures and action gestures. Symbol gestures have a fixed constrained meaning and can be further divided into referential gestures and modalizing gestures. Action gestures include mimetic gestures that mimic the actual interaction behavior and a dietic gesture with a direction indicating function. According to different interaction methods, gestures can be classified into media gestures, direct contact gestures, and non direct contact gestures, depending on the interaction mode. Media gestures are a single point input device through physical contact, such as mouse, a joystick, or a trackball, to transmit the obtained data series into the computing system. Direct contact gestures are gesture operations directly on the input device through part of the body or a physical object tool. When the user touches a device such as a screen, the gesture interaction is turned on, and the touch movement is an intermediate state of the interaction. Direct contact gestures also include a single touch gesture and a multi touch gesture. The single touch gesture is a gesture operation provided by the user through a single point of interest using a pointing input device such as a mouse or a pen, or a body part such as a hand. A pen gesture is a typical single touch gesture that records the movement trajectory of a pen and uses a symbol or a logo for intention expression. Compared to a single touch gesture, a multi touch gesture is a gesture operation through input devices and multiple regions of interest of the body. Non-direct contact gestures refer to an operation of conducting an interactive command through a body part or a physical object without physical contact with the system. Unlike the direct contact gestures, the non-direct contact gestures do not directly touch any input device or surface during operation. For example, vision camera based gesture interaction. According to the different scopes of interaction, gestures can be classified into stroke gestures and mid-air gestures. The former is used mainly on a support surface based on a handwriting gesture of the upper part of the wrist. That is, the user directly uses the hand or tool to move on the support surface and communicate with the computer for information exchange, such as touch interaction screens. The mid-air gesture is based on the user's limbs or interactive devices moving in a space without a supported surface. That is, the user's limbs or interactive tools are not in contact with the computer while interacting in a 3D space. The stroke gesture has a relatively simple interaction mode and low flexibility, whereas the mid-air gesture has a higher degree of freedom of interaction and more representation modes. Compared with the former, the interaction range of the latter is usually large, but it lacks capture ability for action details, and as a result, the recognition accuracy of detailed action is insufficient. According to different display modes, mid-air gesture interaction scenes can be divided into 3D virtual scenes based on a traditional desktop display and VR scenes based on a helmet-like device. Although the traditional desktop display can present a 3D virtual scene, the user usually needs to conduct a gesture interaction within a certain distance of the fixed display. Display environments based on helmets or other off the table environments allow the user to stay free of the limitations of the device and the environment, which further increases the range of gesture interaction. Of course, when using the helmet display, although the spatial range is increased for user's activity, the user cannot interact on a fixed surface. In this situation, it is an effective choice to use non contact 3D gestures for interaction. There are a variety of gesture interaction devices used for VR interaction, which enable users to interact more realistically with objects in the virtual world. For different input devices, the gesture information can be classified into variable sensor device based input, touch device based input, and computer vision interaction device based input. Variable sensor based user interaction devices mainly include data gloves and accelerometers. Touch based interactive devices mainly include the capacitive touchscreen and the resistive touchscreen. It is worth mentioning that some devices which have direct contact with the user could have a certain degree of impact on the user's health. For example, mechanical sensor materials may cause allergic symptoms in some users. Computer vision device based interaction mainly refers to the input through the camera, including single camera, binocular camera, and a depth camera. This method does not require direct contact and is more user friendly, but the configuration and the processing method of the device is relatively complicated. There are also many gesture interaction output display devices in VR, such as computer monitors, VR glasses, and VR helmets. Users can select appropriate input and output devices according to different interaction scenarios in order to build a gesture interaction system in the VR environment. To summarize the lecture, today we learned about the definition and importance of gesture in virtual reality. We then studied about various classification of gestures such as the spatiotemporal, interaction, and scope of interaction. We further then got an idea of the gesture interaction devices also. In the next lecture, we will learn about another aspect of virtual reality, which is the importance of sound. Like gesture, sound also plays a key role in virtual reality. Thank you very much.